All right, hi guys. So the daily poll was a little bit like all over the map today. Some of you guys wanted questions 1 and 2. Some of you wanted questions 5 and 6, and then a couple of you wanted question 7. So I'll kind of go through each of those very briefly so that I can touch on all of your questions and concerns. So number 1 says if f of x plus 2 equals x squared minus x plus 9, then what is the value of f of negative 6? So this negative 6 value that they're giving me is the x value. So the first thing I need to plug that into is I need to plug it in on this inner parenthesis part of the function, and that's going to tell me what f of x plus 2 is. So if I take x, which is negative 6, plus 2, I get negative 4. Okay, so really what I should be evaluating right now is what is f of negative 4 in the given function. Okay, so I'm going to plug negative 4 in. And then we're going to solve that. So you would get positive 16 plus 4 plus 9, and you would end up with 29. Choice B. Okay, question 2, a little bit trickier. It says if g of x plus 3 equals 2x or x squared plus 2x plus 1, then which of the following gives the function g of x? So I would think of g of x as like your original function. And then g of x plus 3 is the same function, function g, but it's shifted over. And since we're adding 3 to x, the shift is horizontally on the x-axis. And remember that shifts on the x-axis should be opposite to the sign. So x plus 3 really means it's shifted to the left 3 units. Okay, so I'm given that function that's shifted to the left 3 units. It's given in standard form, and it's quadratic, so that means it's going to be a parabola. I'm going to turn my iPad this way. So then when I graph this, I can use the equation to get the vertex. B equals, or sorry, not B, x equals opposite of B over 2 times A. So this is going to end up being negative 1 for x. And then I could plug in y, or plug in negative 1 to get y. So I'm doing that right now. This is going to end up giving me a y value of 0. So the vertex is negative 1, 0. And then because it's quadratic, it's a parabola, and it's facing up. So I'm just going to kind of draw a sketch of it. The graph would look like this. All right, so as a reminder, this is the graph that's shifted left 3 units, because this was the equation for g of x plus 3. So if I want g of x should be in the original place. So I need to, since this one was shifted to the left 3, I'm going to go to the right 3 units and make that same graph. So here I went 1, 2, 3 units. Okay. All right, so this vertex here is on the x-axis. The x value is positive 2. Since it's on the x-axis, I think the easiest way to create an equation for this would be to put it in like factored form, because anything that's on the x-axis or x-intercepts give me factors for the polynomial. So I would write this as x minus 2 Since the vertex, since the graph like bounces at that vertex, meaning it hits the vertex and it goes back up, this is x minus 2 times x minus 2. And then I would go ahead and distribute. And that would get me the original equation here. So this is x squared minus 4x plus 4, which is choice B. All right, so that one's pretty tricky. That requires a lot of Algebra 2 memory and kind of thinking outside the box as well. So just to backtrack on what I did, the original graph was what I wanted. The function that they gave me was the function that shifted to the left 3. So if I could figure out what that function is that shifted to the left 3, I'm going to shift it back over to the right, which is going to give me the original one, and then I'm going to try to create an equation of the original one. All right, so that's questions 1 and 2. I'm going to scroll down now to question 5, since that was the next one some of you had questions on. Question 5 is exponential, and it's pertaining to the graph above. It asks, what is the exact value of g of negative 4? So that's an x value, and now the reason that that's probably tricky is because you can't really determine that on the graph. Like I just put the point where x is negative 4, but you're going to have to estimate what y is. So because they want an exact value, what I need here is I need an equation for this graph. Okay, since it's exponential, it uses the equation y equals a to the x power. So really what I need to figure out for this graph is I need to figure out what a is. Okay, so what I'm going to do here is I'm going to pick a point. For example, I'll pick this point right here. I want to pick a point that goes through 2 grid lines very nicely. So that's why I chose that one. This point is 1, 3. I'm going to plug that in for x and for y. And that's going to allow me to solve for a. So I have 3 equals a to the first power, so a is 3. So now my equation for this graph is y equals 3 to the x power. So now I can essentially plug in any x value and figure out what y is. So since I wanted to evaluate the function when x is negative 4, I'm going to plug in negative 4 for x. And then I'm going to solve for y. Okay, a negative exponent means that the base moves down. So this is 1 over 3 to the positive 4th. 3 to the 4th is 81. So the y value is 1 over 81. So in your grid in, you should be putting 1/81. I won't fill in the bubbles on here. All right, some of you also had a question on problem 6. It says, if the expression is rewritten in the form a plus 4 over 3x minus 2, which of the following gives a in terms of x? Basically, these are 2 different ways of writing the same thing, which means I'm going to set them equal to each other. Okay, so I'll write that out here. All right, now whenever I have fractions, I've noticed a lot of times with the SAT problems we've tried to clear the denominator. So I'm going to get rid of 3x minus 2 on the bottom by multiplying it here. So if I distribute it to the first term, it's just going to cancel with the bottom, so I get 9x squared. If I distribute it to the second term here, I have a times 3x minus 2. And if I distribute it to this last one over here, the 3x minus 2's would cancel, so I just end up with 4. All right, now we're not actually going to be able to solve this and get like a final numerical answer. It just wants us to solve for a, and then in terms of x just means that x is the additional variable. So basically, my goal is to try to get a alone. So my first step would be to subtract 4. So I get 9x squared minus 4. Okay, then I would divide by 3x minus 2. So these would cancel out. And now that doesn't look like it's an answer, which means that we might be able to simplify this more. And the reason we can simplify it more is because on the numerator, that's a difference of 2 squares. So you can factor it as 3x minus 2 times 3x plus 2. And so now the 3x minus 2's will cancel. So your final answer for A should be 3x plus 2, so choice B. All right, I'm just going to kind of briefly explain number 7. It's not as bad as you would actually imagine. It's asking which of the following is divisible by 2x plus 5. All that means is that you want to be able to factor the polynomial, and 2x plus 5 should be a factor of the polynomial. Okay, because if it's a factor, let's say 2x plus 5 along with 3x plus 2 is a factor. Okay, then that, since it's a factor, if I divided 2x plus 5, those would evenly cancel. If 2x plus 5 was not a factor, then they would not evenly cancel. It's the same thing as if I had, like my number 24, the factors are 4 times 6, for example. So 4 is divisible by 24 because it's a factor of 24. Okay. So what you would do then is take those original equations up there, and then first perform the polynomial operation. So here I would add function p with function q. Whatever I get as my final answer for those, I think you'd end up with 8x squared plus 14x minus 3 if you add those. Then try to factor it. And if 2x plus 5 is a factor, then that means it's divisible by 2x plus 5. So that would be your answer choice. So in this one, if I try to factor this, and I multiply 8 here using slide and divide, there are no factors of 24 that would add or subtract to 14. So this one's not factorable, so A is not the correct answer. Okay, so I think you guys should be fine on that one now. I will post my solutions at 5 if you're still a little bit confused. But again, you're basically just wanting to do the polynomial operation to get a new polynomial, and then you want to factor it and get the factor 2x plus 5. All right, I hope this helps. Remember, today was the most challenging day for the week, so these ones should have been difficult. And tomorrow will be just review from the week. We'll just work on different sorts of problems throughout the week. Okay, have a great